Okay, does my shirt look okay? Oh, yeah, right. Pictures. Here we have our Inco mill, which, if you hadn't seen it, we did a little quick video on using the fourth axis on a Bridgeport style mill. You can see it setting on a bench. This is up at a mine, and it has an adapter plate that's underneath there. That adapter plate allows the ram to swing around, and that's what we started with to work on the 994. This is a structure that's welded in to the 994. That tubing, I believe, is half-inch wall, 8-inch by 8-inch. Those C clamps are 12-inch extra heavy-duty boiler clamps, and that allows us to move that to different places as we change for what we want to mill. Here is the mill setting in position, showing the base again. And here it is on a cut with the smaller of the two cutters that we're using. You can see we've got a right angle head on the mill and a single cutter, fly cutter with inserts. We actually extended the tool as far as for making the cut depth. And then the quill was used to get us positioned more accurately towards the wall. And all four screws while on the base, while it took a while to square it up for the cut that we needed to make. This is for one of the other pads here. You can see that's surfacing off a, I think that was a little over 12-inch by about 10-inch on that pad there. Here we have the mill covered over with a blanket while we welded a, there's some lighter 2.5-inch square tube that's up at the top of the frame that we made for the mill. That's so that we can hook come-alongs on it to get the mill up and down. Here was one of the come-alongs that we used for pulling the mill pieces up. And here we're bringing it up in pieces. We've got the base and the ram in place. And there's another picture of that. This is showing the feed reduction that we had as we fed the ram in and out for actually making the cuts. The first time that we did this on two different machines. The first time that we did this, we didn't have any gear reduction. We just had a 4-foot long breaker bar, and it was a little tedious to get a nice even cut with it. We managed to do it, but towards the end of that, we borrowed a reducer, a torque multiplier, out of their tool crib. But then, since we had a better torque multiplier, we brought our own along next time. This one here is what this is. The reason I've got this picture in here is if you look over to the right, you'll see that piece of channel. I don't remember, that's 3 or 4-inch channel, and it's coming down at an angle to that main 8 by 8-inch tube. And that's one of the things when you're doing portable machine work, lots of bracing. It seems like your piece is stout that you put on there, but you've got to get to multiple places on the machine itself so you can get a good solid foundation to mill off of. Here's some more of the cross bracing. You can see just a little bit everywhere. It's definitely an art, and every time we welded the cross bracing in, it was a little bit different. That was the support for the mill after we cut it out right at the end of the job of milling the flats. This was on the first machine we did. The first one, we only milled the pads. The second one was actually a lot worse. The pads were torn up to where we had to have some of the holes. The mine did their own welding crew welded up for us, but we welded the holes shut and re-drilled and tapped new holes also because the bolt holes had moved to the wrong location. This is how we were measuring to check out straightness. If you look at, we were holding this by hand the first time we did it, but towards the end of that we figured out that we could use those springs on a pole and adjust them, hold it a lot nicer. The little light rope that's there is in case we do twang it off of the springs, because you've got to play with it a little bit to get the spring right underneath your place where your gauge blocks are holding it. The part that's on our left, if you look at that, you'll notice there's a 1, 2, 3 block along with some other gauge blocks for the height there. That's because there's an offset in these. The two surfaces needed to be machined parallel to each other within a high accuracy, but there's also a offset of, I forget how many millimeters it was. I'm thinking 70. Seems about right looking at the picture, but it could have been 90. I don't remember for sure. Here's another place where we're measuring. You can see that we have a round go, no-go gauge there. I don't know which one that, well, it's not a go, it's a pin gauge, excuse me. Pin gauge of a given size. We know the size. And then what we do, if you look over to, that's at the far right. If you look to the left of it a little bit, you'll see on the surface where there's a gap between the straight edge and the machined part. By using a telescoping gauge in there and then miking the telescoping gauge, that will tell us how much we're out of square or how much more we need to machine between the measurement on this side and the measurement on the opposite side. And the tough one is figuring out your very first one, because you sort of have to estimate where the metal is still good in the first one, that you're referencing off of one and machining the opposite side. So the one you're referencing off of, you haven't machined it yet, and you want to end up still square enough and close enough to size for it so that when you get back to it, projected off of the good side, because once you machine a good side, that's the one you want to project off of to get an absolutely two matching planes. So it's a little tough picking the best spot in that, but it's patience. It can be done. Here we are again. You can see a little bit longer gap. And this is one there, when you look at that pad, that we haven't machined yet. We were taking a measurement off of this one and it hadn't been machined yet. It was just rough. So what we would do when we'd get where it's just rough is basically, we knew we were going to take 50 thousandths off of everything. So you just subtract 50 thousandths from all your measurements that you actually take on this, and you work off of that information, figuring that this is going to be 50 thousandths further up than what it measures. Here we figured out later on that square gauge blocks work too, and they were a little bit easier than fighting with the pin gauges that wanted to roll. And this is, again, this is one of the ones, in fact, this is one of the ones where we had to drill and tap the holes. You can see there's a big pass a little bit from the closest end of the cameraman. There's a big hole in there, and that's because all of this here, I think, needed to go down about a ½ an inch on this part here. This was a very rough re-weld on this part. We wanted lots of extra material. This one's a pretty good pad that hadn't been machined yet, one of the better positions. There's where we're using the pin gauges again. Another picture of our bar. And there is one of the pads. This was the second pad that we machined on the first machine, and we had it, it was needed another 30 thousandths at this point, and so I was afraid that the outside and that middle that hadn't cleaned up yet wasn't going to make it, so I went ahead and went in with some 332 stick and filled all of that in once and machined it from there, instead of having to worry about whether that cleaned up that little bit of trace there. And this is that pad finished off. Here's a start on another one. This is one of the bigger pads again. That is Mark there, by the way. Mark is no longer with us. He has gone on to other employment. Darn him anyway. Good guy. Mark worked for me for quite a few years, and he decided he didn't want to be an ice cube. Even though he grew up here, he moved down to America. And I think it's Arizona. Is it Arizona? I think so. I think it was somewhere around Phoenix. Anyway, he moved to warm weather. There's Mark again. And you can see our cutter right there. That's a smaller diameter cutter, and it's pretty easy to see where we've got a square place that insert cutter goes into, and we put an indicator behind it, slide it in and out for our depth of cut. Obviously, we were doing some figuring on the metal that was nearby there, as all kinds of times we do. And a little bit of marking there. You can see some chips coming off towards the end. You can see the depth of cut actually if you look up towards the pad at the right. We're moving towards the right on this cut. This is one of the wide cuts, so all of that part that's painted yellow right now would have been getting removed. This one here, not exactly sure why I put the picture in there, but it's more of the same. Maybe just going to the other side again. Here is where Mark is in there actually making a new adjustment for depth. Here's one that's showing, and I got this one. I definitely know why I left this one. You can see on top of the ram there. You can cut a lot more metal and do a nice finish, keep it straight. It's rather amazing what you can do with that ram for a milling feed. That cutter is approximately 12-inch. It's heavy. The flywheel weight makes up a lot for the fact that you're sticking out there a little bit, and it would actually cut quite a bit. Now we're on to doing the bolt holes on this one, and to do the bolt holes, we weren't going to lay them out and fuss around and wonder about it. We came in on our boring mill, and we made this template on our boring mill. If you look up above it to the left, you can see a gap there. We've got spacer rings that we faced underneath that of tubing along with the bolts, and that lets it set to the right height for the offset that's in between the two sets of pads. We have the mag drill down there at the far end of our picture. If you can't really see which bit that I'm using, you can see that on the two diagonals, because I think we flipped the plate around for some of our, or flipped it over. We did something anyway to make it where it's multi-position, but also can be bolted down as we go and get more places to hold it. The eye bolts and the cable are there to support the mag drill in case we lose power or mess up. They're, we could hold the mag drill up there. It was just that you didn't want it dropping unexpectedly. There's our little come along up above there, and that was being used off of those same supports we already had. However, this time we were using it to raise the plate up into position. There's plenty of crane support in the shop, nice shop we were working in, but we didn't have any access underneath the machine to the crane because you couldn't get it through all the engine and transmission and stuff above you. This is the close-up of the plate, and the holes in here, I don't remember why we marked the ones with the 4 points a little bit different, but those are signifying one of the two functions, and one of them is to hold clamps on for the mag drill. Besides putting the mag drill on, then we used clamps to hold it stronger to make sure that while we were drilling we didn't have to either drill extremely tentatively or that we'd have the problem of the drill falling off. And the marked ones are either for the cable supports or they're for holding down the heel. I think those are the ones for the cable. I think those are for cables at different places. If you look at the bottom of this plate, you see we have bushing that goes in there, and that bushing has got 3 holes that holds it in. It goes into a about 2/1000 inch clearance hole inside so that the bushing will center the drill bit. And in this case, this bushing is for centering our probably 9/16. It might have been half even, I don't remember for sure. Anyway, for our first pilot drill. And we had bushings for everything, including threaded ones for our taps. Now you can see the bit in here with Mark again. And if you look up near the top, at the front of the mag drill, you can see one of the clamps that holds the mag drill a little bit better. If we look at this picture at the back of the mag drill, over there a little bit to the right of center is another clamp up towards the top of the picture. Now we come back here. Mag drill is just plain hanging out at this point. You see we've got some bushings in there. Some of them are for drill holes at this point. The one that's in position bolted on is an extended one that takes the tap, and behind the tap we used a square drive socket that also fit into the alignment bushing, so that when we put the socket on, the socket helped to make sure that the tap held even more square. Let's see, what do we got here? Cables, X's, clamps, more of the same. This is the tapping. As we were tapping it, we had another spring-loaded tubing coming off of the floor, so we didn't have to fight with all of our extensions coming apart. That was Joseph's idea. Joseph is another one of our employees that has now gone on to do other things. I hear he's doing house construction work right now, and that was because I had a slow time. And Joseph actually decided to volunteer and back off on how much time he was working, and then he got to doing other stuff. And so he did stay in Alaska. He's still an Alaskan. Yay for Joseph. Another good hand. And here we have got the job as we're near the end, and I'm just taking a tap by hand. And these were 36 millimeter, I think it was 4 millimeter pitch. Anyway, they're 36 millimeter bolt holes is what the size of them was. They're fairly good bolts, fairly good size bolts. And I wanted to make sure that the tap got its full depth. And in fact, I don't know if that's the, no, that's the bigger pad. On this pad here, getting full depth was a bit of a problem. You can see the second hole down from the top of this picture here, where it looks like there's something in the bottom of the hole. Well, there was. The truth was there was a brace plate that went above this mount, and this mount was totally made new before we put in the bolts, because the old one was just it was torn up. And I hadn't realized how close the upper brace plate was, nor had anybody else. And you got to really watch that. If you happen to be doing one of these on a 994 and you are fabricating new mounts, watch that upper brace plate. I think it comes in at about 30 degrees. Very critical for angle and position, or you will have to fight to get that last half a thread of enough threads, you know, get your tap in there enough to get that last little bit for the bolt to go in far enough, because it's meant to go all the way through that plate with no obstruction on the top of it. Here we're looking at the couple of the mounts, left and right, finished, threaded, and the ones on the other side, finished and threaded. Just another view of those mounts. And when I got done with all of this, I take and I put my bars up there. I do cross diagonal measurements, and you can only do so much in the field, but as near as I could tell, the worst out of the two machines, I was off about 4 thousandths as far as being a flat plane, which I'm sure is every bit as good as Cat did when they originally kicked it out with a 250 RMS surface on it when it was new. And we thank you for doing all the good stuff, and we try to be friendly and help all of our fellow machinists out there, along with just having fun. And you have a good day.